Hi, I'm Dan Cortopassi. Welcome to the SP Consist build. In this series, I'm working on HO scale models of 5 locomotives I saw on the front of a Southern Pacific freight train in 1993 in Truckee, California. This episode is going to focus once more on the Conrail unit, number 6283. I'll be installing the decoder and getting the unit running. In the last episode, I installed a cab interior in my Conrail SD40, number 6283. The episodes before that showed how I installed lighting and a speaker. The model is now ready for a DCC sound decoder. My goals for this time are to prepare the chassis, install the decoder, and reassemble the model. Right now the chassis is partly disassembled. The front truck and drive shaft are not attached. Most of the wiring is gone, along with the original Cotton light board, which I discarded long ago. As I mentioned in previous episodes, this is a model that I built years ago. I took it apart as part of the Consist build project to rebuild it and bring it up to my current standards. That means that some things are already done. The wheel faces on the trucks have been painted, most likely with Polyscale or Model Master Railroad Tie Brown. All of the wheels have been checked to make sure they're in gauge. These also have a modification I was doing for a while with the intent to help improve electrical pickup. I added some pieces of 010 brass wire that act as wipers on the top of the wheels. These are soldered to the metal pieces behind the plastic side frames on either side of the truck. I did this to some of the models that I built a few years ago. I'm not sure how much it actually helps, so I stopped adding the additional wire. Since these are already here though, I'll leave them alone. To make the brass wire less visible, I'm going to coat it with some Neolube. This is a liquid graphite lubricant that is conductive and has the added benefit of blackening the parts it's applied to. I'll use a microbrush to put some onto the wires and solder joints. The Neolube makes the wires a lot less obvious. Once the model is together and they're in shadow under the sill, they'll be all but invisible. While I'm at it, I'll also put some Neolube on the axle bearings. On Cotton models, the metal axle bearings are conductive, and this is how power gets from the wheel to the decoder. I'm trying not to get Neolube on the wheel faces, but I'm not that worried about it either. If I do, it'll just add to the weathering. Speaking of weathering, this is a good time to add some. I like to weather wheels in layers. They already have brown paint. This is some dark brown weathering powder from Bragdon. They have several shades and I don't remember which one this is, but any dark brown will do. These powders are self-adhesive, so they'll stay put after being applied. I'll use a microbrush to put some powder on each wheel. Having the truck off the model is helpful since I can spin the wheels while I'm doing this. Layering the powder on top of the paint helps to recreate the nondescript dusty brown look typical of real railroad wheels. It's also dead flat. Only the wheel treads on a train should be shiny. There's a hole in the top of the truck that fits onto a pin on the bottom of the chassis. I'm going to put the front truck back on. Before I install the front drive shaft, I'll put a dab of Labelle 106 white grease on the hexagonal end that engages the flywheel. Always use plastic-compatible lubricants on a model train and use them sparingly. The train shouldn't be swimming in grease and oil. Some real diesels may leak fluids, but models shouldn't. I'll use the same grease on the worm. A small dab is all that's needed. This will work its way down into the truck gears as the model runs. I'll put a drop of plastic-compatible oil on the worm bearings. Again, I'm using very small amounts. I'm using Atlas Conductilube because I have it handy, though conductivity isn't needed on these particular parts. Clips on the truck's gear tower engage holes in the worm cover. Make sure that the cover clicks into place when reinstalling it. The Cotton motor mount is designed to have a light board screwed into the holes at the top. The light board for this model is long gone, and the inside is crowded enough that I don't want to try to replace it. One issue is that the motor can now wiggle. This is a potential problem when operating the engine. To fix this, I'll need to pull the motor. I'll need to remove the 2 screws on the bottom of the fuel tank. Now the motor assembly will pull out. Thankfully, I didn't have to remove the trucks again. It's important to pay attention to the orientation of the motor. Mine has a dot of white paint on the side near the top. I also left a stub of orange wire from my previous DCC installation on the top brush contact. The brush contacts face the front of the engine. While I have the motor out, I want to deal with the lower brush contact. The copper strip has become bent and tends to snag on the shell. I'm going to cut most of it off. I'll replace it with wire. This is high flex 36 gauge stranded wire from ESU. It comes in a variety of colors. Per standard DCC practice, I'll use orange and gray for the motor leads. I like to use a fingernail to pull the insulation off the end of the wire. This ensures that I won't cut any of the copper strands. I like to tin the ends of the wires before attempting to solder them. I've cut lengths of orange and gray wire that are probably longer than they'll need to be, but it's better not to have them come out too short. The gray wire especially will be hard to access where it connects to the motor. I'll tin the brush contact stub on the bottom of the motor as well. Now I can solder the gray wire. A piece of Kapton tape will help to hold it against the motor and to keep it from snagging on the shell. Now I can remove the stub of orange wire from the previous DCC installation and replace it with a new wire. The motor mount is in two pieces. Both are made of a flexible material. They can spin around the motor but can't be removed without pulling the flywheels. Thankfully, I don't need to remove them. I'm going to use some clear silicone to help stabilize the motor. This one is by Loctite. I'll put a bead of silicone on the motor mount. Then I'll press the motor and mount together and wipe off any excess. I'm being careful not to get any silicone on the motor shaft. Now I can put the motor back into the chassis. Reconnecting the drive shafts can be a little tricky. Once the silicone cures, the motor should no longer be able to rock back and forth inside the mount. Looking at prototype photos, I found that the fuel tank details on the model are mostly correct. I don't have a good fireman's side shot of 6283, but I found some other Conrail SD40s with close numbers, and the only thing I saw is that the fuel gauge detail is not present on that side. Cotto fuel tanks are split in half and have clips near the center that hold them together. Release those and the tank will come apart. Now I can work on removing the fuel gauge detail from the fireman's side. I found some round plastic sprue in my scrap box that's about the same diameter as the fuel gauge. I'll pick out a drill bit that's about the same size as the sprue. Now I'll drill out the fuel gauge. I'm holding the bit in my fingers for this job. The plastic drills pretty easily, and sometimes it's better to go slow and not risk melting things by using power tools. I'll cut a short length of sprue. Then I'll insert the sprue into the hole in the fuel tank and secure it with some liquid styrene cement. After the glue dries, I'll trim down any excess first with a hobby knife and then some 320 grit sandpaper. I test the patch area often by running my finger over it. I keep sanding until I can't feel a bump. I'm being careful to avoid damaging the other details on the fuel tank while I'm doing this. This is Squadron Gray Putty. I'll apply a little over the patched area. Once it's dry, I'll sand it with 320 followed by 400 grit sandpaper. When it's done, the putty should be all but gone. It's only there to fill any gaps between the tank and the sprue patch. I like to use some paint to test to see if the puttying and sanding worked. The color doesn't really matter for this part. I'm using gray because it covers well. After the paint dries, I look for any traces of seams. This is looking pretty good. Now I've sanded off the test paint with some 400 grit paper. Since I'm going to have to repaint the fuel tank anyway, I'll give both sides a light sanding with some 600 grit paper. Even though I didn't change anything on the engineer's side, I want to paint both sides so that they'll match. Sanding will roughen the surface slightly and give the new paint something to stick to. After washing the tank halves and leaving them to dry overnight, I've taped them to a piece of scrap wood for painting. Even though I'm going to paint them black, I still like to use a primer. This is Tamiya light gray fine surface primer. The primer coat is a good final test to see if the fuel gauge is really gone. It looks like I got it. After the primer is dry, I'll airbrush the tank halves with Testor's Model Master Engine Black. I like to thin Model Master paint with a few drops of Windex for airbrushing. Now I need to repaint some of the fuel tank details. I'll be using Model Master Caboose Red and a 20-0 brush. Red covers poorly, especially over black, so I'll need a couple of coats. My photo shows a small light-colored circle in the middle of the fuel gauge. I'll use a little Model Master Reefer White to highlight the raised dot in the center. Before I put the fuel tank back on, I want to make room for one more detail. This is Details West Part 139, an air filter set. On Conrail 6283, these were located near the front of the fuel tank under the sill on the engineer's side. To make room, I'll need to notch the frame. I've removed the front truck again to keep it out of harm's way and wrapped the motor in a paper towel to protect it while I'm cutting. I'm using a fiber-reinforced cutting wheel in my motor tool. I'll finish off the notch with a file. I'll also need to put a small notch in the top corner of the engineer's side fuel tank half. It would have been better if I'd realized this before I painted it, but this area will hardly be visible anyway. Now I can reassemble the chassis and snap the fuel tank halves together. I'll use a little black paint to make the notches that I cut for the air filter and ground lights less visible. Since I'm adding these to a model that's already painted and I don't want to risk putting holes in the walkways, I'm not going to use the mounting pins in the air filter details. I'll use a number 76 drill bit to drill out the air filter details for plumbing. The trick is to drill part way into one side, then go around and drill from the other side. The holes will usually meet in the middle, making a neat path through the part. I've used some 019 brass wire to make some rudimentary plumbing, glued through the holes that I drilled in the parts. This isn't necessarily exactly like what's on the real engine. I want to make sure it will fit without interfering when mating the shell to the chassis. I'll paint them black with a brush. I'm going to hold off gluing these parts on until the engine is a little further along. I'll set them aside for now. I also used some 019 brass wire to make some plumbing for the rear of the air reservoirs. When I took the locomotive apart to rebuild it, I cut the wires coming up from the trucks. I'll need to splice new wires so that the locomotive can pick up power from the track. I like to pre-tin any wires that I need to splice, as it makes soldering them together easier. The black wire goes on the fireman's side and the red wire goes on the engineer's side. After splicing, I'll slide a length of 132 heat shrink tubing over the wire. Then I can use the soldering iron to shrink it. I've done 3-way splices to connect the wires from the front and rear trucks and left a piece to go up into the locomotive. With the heat shrink tubing on, the wires from the front truck tuck into the clips built into the chassis. Also, in the interest of keeping things neat, I've put some Kapton tape to hold the wires to the motor. I put a length of 1/16 heat shrink tubing over both wires that go to the rear truck. And I put a length of the same tubing to hold the 4 wires that will go up into the shell together. The chassis is now ready to go back into the shell. For this engine, I'll be using a Loksound 5 DCC sound decoder. ESU sells versions of this decoder with various wire and pin combinations for different installations. This decoder came with an 8-pin plug. I won't need the plug for this model, so I'll snip it off. Generally, a decoder can either be installed in the chassis or in the shell. For locomotives like this one with a lot of lights, I prefer to put the decoder in the shell. Since most of the connections will also be in the shell, I'll only need 4 wires between the shell and the chassis, 2 for the motor and 2 for track power. I'm also going to be using a Loksound power pack. This is a capacitor circuit that will keep the locomotive moving for a few seconds if it loses contact with the rails. Planning is an important part of any decoder installation. Especially with a custom model like this, it's important to make a note of any areas on the chassis that stick up into the shell. It looks like there's plenty of room for the decoder above the motor, and the power pack can be tucked in near the speaker enclosure. I'll start by connecting the power pack to the decoder. I'm cutting away some of the protective plastic to expose the solder pads where the power pack attaches. I've also exposed the pads on the other side, which are additional lighting function outputs. It's been a little while since I worked on this model, so I went back with my homemade LED light tester to figure out which wires went to which lights. I've labeled some of them with pieces of tape to make it easier to remember which is which. If you want to see how I set up the lighting in this model, please refer back to episodes 9 and 10 of the SP Consist Build series. It's important to be clear about what needs to be connected before soldering wires to the decoder. I'll need to assign each light or set of lights that needs independent control to a different lighting output. This model has front headlight, rear headlight, number boards front and rear, front class lights, rear class lights, cab light, and ground lights. By convention, the front headlight will be connected to the white wire and the rear headlight will be connected to the yellow wire. All the others are up for grabs. ESU names the lighting outputs on their 5 series decoders aux followed by a number. My assignments are arbitrary, but it's good to make a plan. All the number boards can go to the same output since they will always operate together. I'll go ahead and use aux 1 for those, which is the green wire. I'll put the front class lights on aux 2, which is the purple wire. The turquoise wire is aux 3, and I'll use that for the rear class lights. The pink wire is aux 4, and that'll be the cab light. That leaves the ground lights. I'll need to add another wire for that and use one of the additional contacts, aux 5 through 8. I'll start soldering with the decoder outside the shell since it's much easier to access that way. I want to leave enough slack in the wires so that I can maneuver the decoder, but not too much, as excess wire can make it difficult to reassemble the locomotive. Excess wire can also rub on the drivetrain, which can make unwanted noise and sometimes cause mechanical issues. Some time ago now, I made up a set of 3mm warm white LEDs for the headlights. Each of these LEDs has a 750 ohm resistor under the shrink tubing. The front and rear headlights use paired 030 fiber optic strands. I tied the inside ends of the strands together with a shrink tubing sleeve. I'm going to use some 1/8 shrink tubing over the 3mm LEDs. This will help to hold them in alignment with the fiber optics. Shrinking the area behind the LED will help to prevent light leaks. I'm going to cut the yellow wires from the decoder and rear headlight about here. Before splicing wires, I like to pre-tin the ends. Then I'll put some heat shrink tubing over one of the wires. The tubing is about 1/32. It's good to have a variety of shrink tubing sizes on hand when doing decoder installs. Now I can solder the two ends together. When I'm happy with the joint, I can put the tubing over it and use the soldering iron to shrink it. With a sound decoder, the speaker wires also need to be connected. Since this model has only one speaker, the polarity doesn't matter. If this were a multiple speaker install, I'd need to make sure that each speaker was wired the same way so that they'd be in phase for the best sound. I already installed resistors for some of the lights. This set is for the rear number boards. Each LED has its own resistor. I'll go ahead and solder a length of green wire to the resistor. Then I'll insulate it with some shrink tubing. I didn't put resistor pairs in the front class lights or the ground lights, so I'll need to do it now. Since these lights don't have to be super bright, I'll use a pair of 1.5 k ohm resistors for the class lights and 2 k ohms for the ground lights. All of the positive wires can be tied together. These include the blue wires from the decoder and various lights, as well as the green magnet wire that I used for some of the smaller LEDs. I've connected the orange, gray, red, and black wires between the chassis and decoder. All the electrical connections are now complete. Now comes the moment of truth. Before I start to put the model back together, I want to test it. Even though I'm pretty confident in my abilities, I still get a little nervous about putting a model on a live track for the first time. No smoke, that's a good sign. It looks like the headlight LEDs are working. Uh-oh, the direction of travel is backwards. I must have had the orange and gray wires wrong on the motor the first time I built this engine. I could fix it with CV programming, but I'd rather swap the wires. This empty decoder has some peculiar built-in sounds. I'll change that later. Right now, though, I'm happy that all the different lights seem to be working. I've reversed the wires to the motor, and now the engine goes forward when the control is set to forward. The challenge now is to take what looks like a mess and tuck it into the shell as neatly as possible. I'll start with the decoder. I've put a piece of double-sided foam tape on one side. Sorry for not being able to show my work here, but it's pretty hard to do this work inside the shell and have the camera show anything useful. I've used another piece of tape to mount the power pack. The headlights slip over the fiber optic strands that I installed in a prior episode. I made a wire retainer from some scrap styrene. The small side pieces make it easier to glue into the shell. The retainer should keep loose wires out of the drivetrain. Now for another moment of truth. Let's see if all the planning worked. I always go slow when putting the shell on, making sure there are no loose wires getting caught anywhere. I like to make sure that no gaps appear, especially where the sill meets the long hood. It's good to check to make sure that the coupler mounting pads on the chassis align with the openings in the pilot. I'm not going to install the couplers yet. It runs. With the sound off, I don't hear anything scraping on the drivetrain, so I think this one is good. Let's test the lights one more time now that it's together. Everything looks good. I think this is a good place to leave things for now. I'll tackle the final detailing and weathering, including installing the air filter details that I worked on earlier and programming the decoder in future episodes. This model is a little odd for me in that I built it once and then decided to build it again better. The first time around I neglected some things like removing the fuel gauge from the fireman's side of the fuel tank. If I were building this model from the ground up, that would have been done by this point. When a model is this close to being put back together, I think there's a temptation to want to get it done. I'm glad I took the extra time to address a few details on the fuel tank and under the sill. It'll be worth it in the long run. I must have hooked up the orange and gray wires to the motor backwards the first time I built this engine. Instead of checking, I just assumed that I'd done it right. That meant that I had to do a little extra work to swap the wires and correct the issue. I'll admit that all the wires, resistors, shrink tubing, and LEDs inside the shell don't make for the prettiest picture. Thankfully, all of that is on the inside and will never be seen unless I take the model apart again. By the way, I try not to do that. Once I have an engine running and everything is working as it should, I leave it alone and don't take it apart again unless there's a problem. I'm happy that the Conrail unit's running. Now I need to do some more weathering and detailing and program the decoder. I'll be tackling both of those things in future episodes. Stay tuned and thanks for watching.